Hi, my name is Genesis, and today we're going to learn how to convert a quadratic function from the general format to the standard format. And I like to call this standard format the vertex format, and you'll see why later. Normally, the general format of a quadratic function is written in this way. F of x, or f at x, f located at x is equal to ax squared plus bx plus c. And we're going to convert this. Whoops, should go down. And well, before I do that, talk about that. Normally, I like to write f of x as y because f of x is y. Ax squared plus bx plus c. And we're going to convert that to the standard format, which is f at x equals to a times x minus h squared plus k. And like I said before, I like to convert f at x to y. Okay, I just like to do that. It's my habit. But you don't have to, but I think you can follow me and do the same thing. So we're converting a quadratic function from the general format, which is in this format, to this format. And there are two ways to do this. One's the traditional way, which you probably read in many textbooks, and another way is an untraditional way, and it's an easier way to convert to the vertex format or standard format. And the question is why this form? Why is this form so important to us? Well, it's because with this form we seek the vertex, and the vertex we find are located here, this h and this k. The vertex is where it tells us where we are on the graph, where we can begin. And usually in textbooks, you usually see in your textbooks, or you're given a question about something. It's usually in this form, this general format, and then you're asked to graph it. In order to graph it, you need HK. You need the vertex, right? And you also may be asked the axis of symmetry. You may be asked where's the relative maximum or local maximum or global maximum or minimum. You may be asked is this function increasing or decreasing? And this form, if you can convert from the general form to the standard form, it's just the vertex form is just the easiest way to find out the answer to those questions, and that's why we do it this way. And to get to the vertex form, um, this process from converting general form to the vertex form is called something called completing the square. Completing is it's a weird name, but it's called completing the square. Right? Okay, and um, basically what you have here, the idea of before you even think about completing the square, I'm not even going to show you yet. Before you think about doing this, in order to complete the square, the leading coefficient of this guy here, right? There must be an invisible one in front of the whole thing. In other words, I'll write it. The leading coefficient, a, right? That's our leading coefficient, and the whole thing, x squared plus bx plus c. That leading coefficient must be equal to an invisible one, positive invisible one, right? It must be equal to a positive invisible one. Okay? And if a is not an indivisible one, right? If it's like a 5 or a -5 or a -100 or something, then factor this leading coefficient out of this quadratic function before you complete the square. Okay, factor it out. That's the first thing I'm going to say before we learn how to complete the square. I'll move this up. Now let's look at the standard format really quick. If we look at it, we notice here that we have this this term here, right? This expression here looks like this: h minus h2, right? Let's look at that really quick. Now let's look at this. You see that? Notice that this is a perfect square. How you should have learned in Algebra 1, Algebra 2, what perfect squares look like. Perfect squares look essentially look like this: x minus b, right, squared, and that's a square, and that's equal to x minus b. It's repeated twice, so you're going to multiply x minus b times x minus b, right? Right? You learned that, remember? And this will be equal to x squared, right, minus 2bx plus bx. And this the book next goes to take this here. They take this, right? But this is the traditional way. Remember, it's not my way. I'm just showing you how it works. All right, they'll take it out. Let's say, for example, they give us this function here. I mean, they give us this expression here: x squared minus 10x minus 11 equals 0. Let's say they give this to us, right? This will be our a is an indivisible 0, right? By default, there's a 1 here, and this is b, and this is c, right? So what we're going to do is take this here, minus 2bx. That's b, right? So we're going to take minus 2bx, and it equals to -10, right? If we solve it, right? Sorry, I made a mistake. Just a 2b. Minus 2b, okay? We solve for b. We're going to end up with b equals to 5, right? And then 5 squared is what? 5 squared is 25, okay? And so the perfect square that we want from here, if we take this, will look like this: x squared minus 10x. We want here b squared, right, plus 25, right? So that's the perfect square that we want to get at. We want this perfect square in order to change from the general format to the standard format, right? This is how we do it, right? So this will equal to 0. Now before you, like I said before, this is the warning. Before you convert the general format to the standard format, there must be an indivisible 1 before the whole thing, before the whole entire expression, right? So so if there is if there is no indivisible 1 here, there's more than an indivisible 1, like 2 or 5 or 6, right? Factor out that leading coefficient. Just remember that. So there has to be positive 1 in front of that, the whole thing here. And we do have a positive 1 here, right there, right? That's the indivisible 1 right there. Okay, remember that. Okay. Now, what we want to do with quadratic equations, right? When it comes to the actual quadratic equations or quadratic functions, right? We're going to add we're gonna add x. We're gonna add 25 to both sides, like so. It'll be 25 there, right? And we're also gonna add 25 to the other side, right? So let's go back. I'll put the original problem was x squared minus 10x minus 11. And what we're gonna do normally is this. In the traditional way, is that x squared minus 10x, right? We're gonna throw that. We're gonna do that negative 11 on the other side. Then we saw the b squared was 25. So we're going to add 25 to this side, right? Because that's what we want. We want that. We want this perfect square. We threw that negative 11 over this side. Now we're going to add 25 to this side. Why did we do that? Right? Because an equation needs to be balanced. What you do to one side is what you need to do to the other side. Do unto one side what you will do unto the other side. Okay, almost like do unto the others. That principle, the golden rule, right, applies to mathematics as well. Now, once we have this, we're going to solve everything on the right side, right? And we're going to look, and before you do that, you want to look at this side and try to make it a perfect square. And if we look at this, right, in order to make it a perfect square, this will factor out as a perfect square in this way. Okay, remember this is the difficult way, right? That's the perfect square. Look like that. And then you add these two together, right? 11 plus 25 is going to be 36. Okay. And basically you're done. You just move this over, you know, on the other side. And that will be your answer. You know, that's how you convert the general format with this, of this. Where is it? Right here, to the standard format here. And that's the traditional way. Now, for those of you who are scared by this, it's important that you know how to do it. But here's the non-traditional way, easier way, my method, the way I like to teach people how to do it. Leading square. And the way I learned this method from a company called Omega Math. I've been using Omega Math for about 3 years now, and I know everything from Omega Math, and that's why I'm so good at math. And it starts you off with four types of algebra: pre-algebra, beginning algebra, intermediate algebra, college algebra. It moves you on to trigonometry and geometry, you know, and then pre-calculus. They have other stuff like calculus, chemistry, biology, anatomy, a whole bunch of other things, computer science. But you know, mainly it's really good with math. You know, and they really help you out with a lot of things. So I really highly recommend Omega Math. It's not free, but it's very organized, and it helped me. If it can help me, it can help you. Yeah. So. Okay, so well here's the method the method I learned that I also highly recommend to you, and that's also not only easier but a faster way to do this whole thing. What you have to do is first, let's say you're given this problem here. F of x is equal to bx plus c, right, plus ax squared. Now what you got to do is put it in this form here. F at x equals to, make sure it's in this format. Make sure that the leading coefficient is on the left side. Let's see. Make sure it looks like that. And then once you get it like that, you put in your template, right? And I'll show you the template first. But what I like to do first is change this to y, right? Not only do I like changing it to y, I like moving y, switching or moving y over the other side. So I'll change this to y because I like to do that, and do like this. V of x plus c equals to y. All right. Your next step is to move the c over to the other side. So c betrays the left side. If c betrays the left side, it becomes a traitor. And if it's a traitor, it becomes negative, right? If c was negative, it will be positive. But since it's positive, it's going to be negative. So now c is going to betray one side, and it's going to become negative. Okay? So we want it in this format. Once we have it in this format, right? And a is an invisible one, which we will assume that it is, right? Then we're going to put it in something. We're going to put in our template, and a template is what you should always remember from here on out. And it looks like this. Okay, let's assume that it's positive, right? It's positive here. This is positive. Sorry about that. So we have three colors. We have our X. We have question mark. We have another question mark. Squared equals to y minus c is plus over here, so it will also be plus over here, because what we do to one side is what we do to the other side. Okay? Square. Now this template is something that you have to memorize. Once you have it in this format, you put your template, right? And what's going to happen is this. You don't care about the square. What we only care about is the x. What we're going to do is copy what's here. The x will turn to x. That's our template, right? This will be plus. Now this third question mark, this question mark here that you see, the third one, the orange question mark, remember that this orange question mark equals to b over 2. That's something. That's something we have to memorize. Okay, this question mark is b over 2. All right, remember that. Okay, let's put it over here. Our orange question mark equals to b over 2. Right? Good. And what we do to one side is what we do to the other side. So we have two orange question marks on this side, and we have they're both positive on the outside of the parentheses. So let's do a real life example. Let's say that f of x f at x is equal to x squared minus 10x minus 11. We have a here. A is invisible one, right? This is b, and this is c. Remember, the first thing we're going to do is change f at x to y and move it on the other side. So let's do it. So the x squared minus x 10x minus 11 equals to y. Good. Now move c over to the other side. C becomes a traitor. And it was negative on this side, so it's going to be positive on this side. Now we have this format. Now we have all the x's on this side, and it's in this format. We're going to put in a template. Here we go. our template looks like this, and it's positive. Great. So this is positive, and there's an invisible one there. We're just gonna mark that. We have X here. And set up our template. Come on, set up that template. Let's go. Let's go. That's a square. Sorry. Y plus 11. When you get here, you look on the left side, because what you do to one side is what you do to the other side. It's positive, so it's going to be a positive parentheses here. You copy it, and inside the parentheses is an orange question mark, which equals to b over 2. Remember that? It equals to b over 2, that orange question mark. Okay? Squared. Good. Now we look at this above here. It's going to be orange, 10. This is going to be purple. X. And we just copy down. This one goes here. This one goes there. And this one is going to be 10 over b. So let's do it. Okay, we have a parentheses, and it's positive on the outside. Great. And this, copy this, -1. This question mark is -1. I mean negative, not -1. And this orange question mark, remember, is b over 2. So 10 is b, so it's going to be 10 divided by 2. Okay. Let's close the parentheses. Squared equals to y plus 11. And it's positive. Notice it's positive on this side, positive and the parentheses on this side. So we're going to do the same thing. Positive. Okay. Positive parentheses. Okay. And we're going to copy the orange question marks inside. 10 over 2. And let's simplify. Yeah, simplify the left side first. Okay. The answer is going to be x minus 5 squared. And we're done with the left side. It's done. Okay. Y. Let's start with the parentheses. 10 over 2 is 5. Okay. 5 squared plus 11. Okay. 5 squared is 25. 25 plus 11 is going to be 36. Positive 36. Okay. Now we want to isolate the y and get it by itself. So we're going to subtract we're going to subtract 36 out by making it a traitor. So subtract -36, and also what you do to one side is what you do to the other side, right? And we're going to come out with this: x minus 5 squared minus 36 equals to, it crosses out, y. Right? Originally, we're going to put back our f of x and put it back in this format here. F at x equals to x minus 5 squared equals to 36. And that's how you convert a quadratic function from the general format to the standard format. And now we can answer the question, where is the vertex? The vertex is right here. If we take out x minus 5, set it equal to 0, solve for x, x will be equal to 5. That's going to be our h, right? And now we look at this figure here, this number here, our -36. It's not connected to an x, it's not connected to a y. We don't change a thing, we just bring it down. Our k will be equal to -36. So our vertex, I'll label it as v, our vertex hk, which is the same thing as x and y. H is x and k is y. Our vertex is equal to 5 and 36. Okay. And what if they ask us to graph it? I mean, what are the axes? The axis of symmetry, and or where the function is descending or increasing. The best thing to do, what I like to do at these times, is to take the function that we have, look at it. We have here is this here. We notice that the function is not negative. It is what? It's positive, right? Not in there. So since it's positive, we know that it's facing up. So first, let's draw a little graph here. And our vertex is at 5 and negative 36. So let's imagine that this is negative 36 here. Right, it's negative 36. And 1, 2, 3, 4, 5, right? So 5, the vertex is right here. And because this function is positive, it will be facing up in the upward direction. Okay, this is, our vertex is 5, negative 36. So it's going to be facing upward that way. Pointing upwards that way. Forever going up. Our axis of symmetry is going to be 5. X is going to be right here. Remember, we read that on the x-axis. It appears right here where x is equal to 5, right? So our axis of symmetry is AOS is x is equal to 5. Now they will actually for the minimum or the relative maximum. There is no relative maximum. There's only a minimum. And the minimum is read on the y-axis. Okay? If we look down, there's no maximum. If we look down, there's no maximum, right? We go on the y-axis, there's only a minimum. So the answer is the minimum is negative 36, where x is equal to 5. That's how you need to say it and write it. So the minimum, relative minimum, is equal to, or it is negative 36 when x is equal to 5, right? And they may ask you when is its function increasing and when is it decreasing. Remember, we always read a graph from left to right, right? So we start from the left side. This is negative infinity. This is positive infinity. And we ask ourselves the question, when is it decreasing? Okay, we start from negative infinity, we go on the x, and we read the graph we not only do we read the graph from left to right, we read it on the x-axis, okay? It's decreasing. Well, we go from the negative infinity, we go over, and we notice when we touch here, we notice that the graph is falling, right? It's falling, right? And then it stops falling here. And then at this point, where x is equal to 5, it starts to increase, right? And we read it on the x-axis. So the function is decreasing from negative infinity to this point here, 5. Negative infinity to 5. And the function is increasing from 5, look at it, and it goes up here, 5 to forever. It will forever go up to 5 to positive infinity. So it's increasing from 5, this is how you write it, 5 to, that comma means 2, positive infinity. Okay? And I hope this helps you understand how to convert a quadratic function from the general format to the standard format. And there are other problems I would like you to try on your own. For example, I want you to try on your own this problem. F at x is equal to x squared minus 2x minus 15. Okay. Another one, I'm actually going to do this other one with you, but I'm going to try, you can stop the video, pause it, and try this one on your own. Okay, good. Another one I want you to, what we're going to try together is this one. F at x is equal to negative x squared plus 12x minus 13. Another one that I want to do with you is f at x equals to negative 8x squared plus 16x plus 2. So let's first start with this one. Right. You pause the video, you should have turned back on and try to solve this one. Good. So let's do it. Let's change this to y. Let's move y over to the other side. X squared minus 2x minus 15 equals to y. Right? C goes on over to the other side. X squared minus 2x equals to y plus 15. Let's put in our template. X question mark squared y plus 15 is positive. This is also positive. Right? Question mark squared. Well, first thing I see is that's this. 2 goes here. 2 is divided by 2. Okay, so that's what we do to one side is what we do to the other side. 2 is divided by 2. Okay. Now let's simplify it. Okay. 2 divided by 2 is 1. All right. Squared y. This is 2 divided by 2 is 1. Right. One squared is 1. 15 plus 1 is 16. Okay. Now, let's move this baby over to the other side. This should be your answer. F at x or y equals to x minus 1 squared minus 16. And now from this we can get the vertex. Take this out, set it equal to 0. Solve for x equals to 1. That's going to be our h. And this is not connected to x or y, it's going to be our k. So our vertex is 1, h, k, 1 and negative 16. Our axis of symmetry, now that we know our vertex, we know where to start. It's going to be 1. Let's say this is negative 16 here. This is 1. Right there. That's our vertex. 1, negative 16. And it's facing upwards because it's positive. It's a positive one. So it's going to be like this. Okay? Our axis of symmetry is going through here at x. So our axis of symmetry is, our AOS is x is equal to 1. Our minimum, our relative minimum is negative 16 when x is equal to 1. It decreases